Do two cars leave the same place? How many people worked on this one like they were supposed to? Okay. Who worked on this? This was the first question. It was in the notes. I left it yesterday saying, please work on this one. Left it in the notes. Said, this is your first homework question. Oh, anybody work on it? Anybody? Bueller? Let's talk about this one. Two cars leave the same place at the same time. So if they leave the same place at the same time, we're going to start at the same place. So here they are. They're starting right here. One's going east and the other's going. There's your eastbound car and there's your westbound car. The eastbound car is going 40 miles per hour and your westbound car is going 50 miles per hour. So I'm just taking notes as I read this question. And how many hours will they be 300 miles apart? What's the one formula you're going to use when you're dealing with this question? Distance equals rate times time. So one thing you might have seen written many times if you look these up, which I highly recommend you do because the book gives many great examples. Distance equals rate times time. So you have, how many cars are we dealing with? You have the eastbound car, distance, rate, and time. What's the rate of the eastbound car? 40. The westbound car, how fast is it going? 50. To answer this question, is the answer in feet? Is the answer in color units? What's it in? It's in how many hours? Yeah. So what is it in? Hours, right? Do we know how long they have traveled? No, we're trying to answer that question. So we have to label a variable for the amount of time, assign a variable. So what variable do you want to use? Let's use x. And how is the time going to be the same for the east and the westbound cars, or is it going to be different? Different times. Two cars leave at the same place at the same time.
Well, one's going faster than the other.
Does that affect time?
Well, yeah, if you're getting there quicker than the other one.
That's not what it's asking. It's asking how long will it take them to get this many miles apart. So did one car leave before the other car?
Oh, yeah,
no.
Yeah. It would still take the same amount of time.
They're still traveling.
Yeah.
So what I'm saying is, what's the time for the eastbound car going to be? X. What's the time for the westbound car going to be? Wait. Let me finish my sentence first. They're both traveling for the same amount of time. Do you agree?
Yes.
Yes, they are both traveling for the same amount of time. You could label this. You could make a little chart if you wanted to do it this way. Yes, your question, Harrison. Well, eastbound car has traveled. Nope. What's the distance? 40x. What's the distance the westbound car has traveled? 50x. And then you can total this up. So how far have they traveled total after X hours?
300 miles.
No, that's how much. That's the target, but we don't know yet. 300 miles. Sorry, you're correct. They've traveled 300 miles, but by what we just did, one traveled 40x, the other traveled 50x. So how far have they traveled altogether? 90x. So together, they've gone 90x, but you know that 90x has to equal what? 300 miles, exactly. 90x has to equal 300 miles, like this. So what do we solve for now?
How do we?
It's gonna, 90x is equal to 300. So x is equal to 300 over 90, which is 30 over 9. Divided by 3 is 10 over 3 hours. So after 10 over 3 hours, they are 300 miles apart. Labels for each of those numbers to keep them easily straight. Yeah, so we could use P, D, and Q. So the first thing it tells you is P is equal to D. Okay, what else does it tell you, Milo?
The total value is $4.37.
$4.37. So what does it tell you? Anything else?
How many of each denomination of coins does he have?
Excellent. So how many of each? So you have to write a statement of value, correct? If you have P pennies, how many cents do you have? P cents, right? Are we in dollars or cents over here? Dollars. Do you want to stay in dollars, or do you want to go to cents? Let's go to cents. It gets rid of the decimals, right? So this is equal to 437 cents. So if we keep this in, that's the value of the pennies, right? P. Yay. If you have D dimes, how many cents do you have? No. No, we're in pennies now. Sorry, we're in pennies, kids. We're in cents. If you have D dimes, how many cents do you have? 10D. 10D. If you have 100 dimes, what do you multiply that by to get the cents? How many cents is one dime worth, kids? 10 cents. So if you have D dimes, how many cents is that worth? Hold on. Let me ask the question, and then you can respond. Okay. If you have D dimes, how many cents is that worth? Okay. I think I'm speaking. What about quarters? If you have Q quarters, how many cents is Q quarters worth?
25Q.
25Q, exactly. When you add this all, cents, exactly. We are in cents. Yes, and it's really hard to say that word over and over again. That's how many cents together it's all worth, but we need to know that we need to set that equal to what?
437 cents.
437. Okay, so here's the deal. This right here is one equation, but how many variables are in it? 3. So we need to get rid of a couple of them, right? What's the first thing we know? We know that P is equal to D, so we could substitute that in. Are we okay with that? P is equal to D? Yep. So we know that D plus 10D plus 25Q is equal to 437. So again, we have the same equation, but how many variables do we now have? 2. Are we getting closer to having one variable? Yeah. What's the one piece of information we haven't used yet? What's the one piece of information we haven't used yet? 44 coins. There are 44 coins. P is the number of pennies. D is the number of dimes. Q is the number of quarters.
Oh, so you just made D.
So what do we know? Don't. Hold on. All we made is D is equal to P, correct?
Yeah.
To get to this step, correct. So if we know we have 44 coins and we have P pennies, D dimes, and Q quarters, what equation can we form? 44 is equal to what? Yeah, so what is the number of coins? P is the number of pennies. D is the number of dimes. Exactly, right. P plus D plus Q. Which variables do we have in that red box equation? D and Q.
So can we get rid of the P?
We want to get rid of this P right here, so we know P is equal to something. Oh, P is equal to D, right? So, great observation. So if P is equal to D, 44 is equal to what? D plus Q. So 44 is equal to 2D plus Q. Oh, do we have another equation now with P, so with D and Q? We have 2 equations, and both of them have D and Q. If we have 2 equations and 2 variables, theoretically, what can we do? If we have 2 equations and 2 variables, theoretically, what can we do?
We can
Okay, if you have one equation, if we simplify this, what do we end up with? How many D's do we have right here?
2.
No, we don't.
12.
11 of them. 11D plus 25Q is equal to 437. So we have these 2 equations. We love these 2 right here. Yay! Makes us happy. Wonderful. Miss your hand, sorry. So can someone tell me, raise their hand, I'll call on you. What does Q equal over here?
44 minus 2.
Raise your hand. We're going to play a game. It's called I say raise your hand, then you raise it, then I call on you. It's a fun game. Nick.
44 minus 2.
There it is. And now, what can we do with Q? Now that we have Q here. Someone raise their hand. We'll play this game again. You want to go for it, Mar? What can you do?
You said the 2, so it would be 25 times.
Yeah. So now you have 11D plus 25 times 44 minus 2D is equal to 437. Now, how many equations do we have right there? We have 1 equation. How many variables are in it?
1.
Yeah. We have 1 equation and 1 variable. Is that a happy thing?
Yeah.
Is it a happy thing, Aubrey? It is a happy thing. So can you solve that? Theoretically. Solve it, right? Well, we're done with this part of the problem. This is the number of what?
The dimes.
Number of dimes. So that immediately tells us what? 17 pennies. And then how do we find out the number of quarters?
Subtract those numbers
For 44, exactly. So it's going to be 44 minus 17 is 10 quarters. Yay! Okay, put everything away except the pencil, please.
nuts.
See right now, you could if you want to, so these are optional. There's some word problems from yesterday that if you haven't looked at, you should. For this question, for this triangle question right here, I didn't put the question in, but what do you think the question is going to ask? Find x. Yeah, what are the angles? Find x, right? What are the angles? What's the only thing you need to remember about geometry to do this question?
Angle sum.
Angle sum internal for a triangle is 1/8. That's the only fact you need to remember. Solving linear inequalities in one variable. Now, we've looked at this already. We have set builder notation. Remember, I asked you a bunch of times about interval notation on past quizzes, right? And then you have the graph. So you have set builder, interval, and graph. What does this little open thing, what have we been calling the open soft brackets? It gets infinitely close to A, but doesn't contain A. We've been calling those hard brackets, soft and hard brackets. This is just a refresh of what we talked about already. If the arrow extends infinitely to the left, what does that mean you're going to? You're going towards what? Going towards infinity. Can you ever get to infinity?
No.
Because if you ever get a place, it's finite, and therefore it's not infinite. It's the opposite of what we're trying to describe. So what we're going to do instead, we're going to be looking at linear inequalities. So instead of ax plus b equals c, we're going to have ax plus b could be less than c, less than or equal to c, greater than c, or greater than or equals to. So on this linear inequality, which I'm pretty confident you guys could work with, if you wanted to solve for x, what would you have to do to both sides? Add 7 to both sides. If I add 7, I get x is less than -5, which I could write, I could graph that. I could do -5. Is it an open dot or a closed dot at -5? It's going to be an open dot, and then you have to shade a little bit to the left like this. Or you could graph it a different way. You could have -5 and you could do that instead. If you wanted to do this in interval notation, how would you write it in interval notation, Nick? What would interval notation be for this?
It would be
The difficulty level a little bit. What about this one right here? What would you have to do? What do you want to do to both sides first? Harrison, what do you do first?
subtract 2x.
I like subtracting 2x. So we're just going to subtract 2x from both sides. The rules are essentially the same as equality, right? What you do to one side, you have to do to the other. So what do you get? 14 is less than or equal to? Now, we don't really like that. We'd like to switch that around. So if 14 is less than or equal to x, what's another way you could write this?
X is greater than or equal to.
Yeah, we like keeping it, we like reading things left to right. So in this case, you could write it as hard bracket 14 soft bracket infinity. Or you could graph it. You have 14 hard bracket and you go to the right. Okay, so far so good. What's the big thing that's different though? What do we have to watch out for when we're dealing with inequalities? What's the most common mistake people make? Mar?
Flipping
Not flipping the inequality when you...
either divide or multiply by a negative.
Yeah, if you multiply or divide, and I can almost write here, multiply or divide by a negative, what do? Flip the sign. You flip the sign. Right. So on this one right here, Milo, well, if you wanted to solve for x, what do you have to do first on that one? Well, no, we have to do something that induces the flipping of the sign. What mathematical operation do you want to do to both sides? To isolate x, what do you want to do?
Divide by.
Yeah, divide both sides by 5. So you have x something -6. Well, did we multiply or divide by a negative number? No, we didn't. So it's still this. But let's say we had this. What are you going to divide by now, Summer? Yeah, we divide by -5, and we end up with x something -6. What's that going to be? Greater than or equal to. The way you can remember this, or the way you can justify it in your head, think of just give a positive and a negative. -2 is less than 5, is that correct? If I multiply both sides by -1, you get 2 and -5. What does it become? It flips. If you flip the sign, you have to flip the inequality. Essentially, if you remember to do that every single time it's necessary, you'll eliminate 50 to 60% of the errors you make when you're multiplying these out, or when you're solving these. Because mathematically, is it the same as dealing with equations? It's the same as dealing with equations, except for this one thing. So what are we going to do? Simplify each side, isolate the variable on one side, and then isolate the variable overall. You have 4 possible answers. X is less than a constant, x is less than or equal to, x is greater than a constant, or x is greater than or equal to a constant k. 4 possible. What do you have to do first on the left on this side, Aubrey? What one word? Distribute, right. So you end up with negative 3x minus what? Minus 12 plus 2 is greater than or equal to 7 minus x. What should you combine on the left now? Yeah, so you get negative what? 10. And now what do you want to do to both sides, Liv? Add the we don't subtract the 3x.
Or add the 3x.
You could add the 3x if you got. You could. So I'm going to add it. I like that because you end up with plus 2x. And now what do you subtract from both sides? So you get negative 17 greater than or equal to 2x. So what does that tell you? X is less than or equal to negative 17 over 2. Yeah, good job. Exactly, nice. Now on this one right here, we're gonna start this. We're not gonna finish it, but on this one right here, what would be a great first step? Anybody want to guess what a great first step